You are asked to find after 56 days, but X stands for weeks. Suggestions on what I should do. Kirsten. Thank you. Yep, let's do that. And this should be a math fact that you know from elementary school. Thank you. 8 weeks. So you're going to take that 8 and you're going to put it where X is. So what we're doing is we are inputting inputting 8 into this function. So remember when you see f of 8, that does not mean f times 8. It means I'm inputting that into my function. 30 times 2 to the 8th power. As we discussed on Tuesday, you have to do the exponential part first. So 2 to the 8th power, you could either do it in your head or you could do it in your calculator. You do not have to do 2 times 2 times 2 8 times. Remember, you can use that caret key, the one that looks like a roof, to raise it to the 8th. Please do this on your calculator so you actually know how to do it later by yourself. Prove it to yourself that you know. Kayla, what do we get? 256. 30 times 256. And then go ahead and multiply that together. That's a lot of beetles. 7,680 beetles. Thanks. Okay, next one. We did some graphing the other day, so we're going to do some more. Let me remind you, I don't need you to write this down unless you want to. When you have an exponential function, it looks like this. A, the number in front, that's your exponent, or sorry, your y-intercept. And B is what it's multiplying by. So you're looking for the number out in front because that's where you're going to start. This one's a little bit tricky. So you have f of x equals negative 1/2 to the x. You see a negative. What number is out in front right now? Is it 1? No, it's not. What is it? You're close. It's negative 1. So let's rewrite this. This is the same thing as having f of x. This is really what it is. Negative 1 times 1/2 to the x. So you're starting at negative 1, and then you're multiplying by 1/2 every time, or dividing by 2.
I thought you couldn't have an x. That had to be a number.
No, that's when you write the function, it's always going to have an x. I think you're getting it backwards. Okay, so we put negative 1 where x equals 0, because that's my y-intercept, that's where I start. And then as x increases, it's being multiplied by 1/2. Or think about that's the same thing as dividing by 2, but when we're doing exponential functions, we don't say we're dividing, we multiply by a fraction. So negative 1 times 1/2, what would that be? Negative 0.5 or negative 1/2? I'm going to go ahead and use fractions. And then if you multiply by 1/2 again, it'd be what? What's 1/2 times 1/2? 1/4. So negative 1/4. And then 1/4 times 1/2 would be 1/8. So going the other direction, you would be dividing by 1/2 or multiplying by 2. So it should be doubling, obviously, going the other direction. We're going to keep the pattern going, so you should have negative 2, right? Negative 4, negative 8. Because if we're dividing by 2 going to the right, or multiplying by 2 going to the left. Before you draw on your axes, pay attention. Look at your y values. So x values are going to be like the same thing every time. But the y values on this one is different from what we did on Tuesday. This one, they're all negative. And what's the highest it goes? Please don't say negative 8. What's the highest it goes?
-1.
-1/8, so it almost gets to 0, it doesn't, and the lowest it goes is -8. So we are going to make sure that we have plenty of space below the x-axis. Is that my phone? Axes, you need to make sure that everything can fit. So we're going to make sure that the x-axis is pretty high. So up here. Because we need everything below that because we're doing just negatives. We only have to go down to -8, so each of these squares can be worth 1, so we don't have to change the scale this time, which is nice. I don't care where you start. You could start at -3, -8, plot that point. And then we're doing all the rest of them as well. -8. And then -2, -4. I'm looking at these points, right? Each x, y is a pair of numbers that we plot. So -1, -2, that's a point. 0, -1 is a point. And then notice how every time you go, you're just halving the amount, right? You're multiplying by half, and so it's getting, okay, well that was 8 squares, now it's 4, now it's 2, now it's 1, so half, then fourth, then eighth. So it's getting closer to 0. Because it's just cutting in half every time, multiplying by half. Remember, we could connect those with a curved line. This is exponential, but we do not want it to touch 0 because it will never touch 0. If you keep dividing by 2, you'll never actually get to 0. So keep it just below that x-axis. It's close, but it's not actually going to touch it. And we're going to answer 3 questions on the side, at the bottom. Domain, we talked about on Tuesday. Domain is from left to right. What would my domain be? Does it ever stop going to the left? Does it ever stop going to the left? No. Does it ever stop going to the right? No. So Jackson, what's my domain? All real numbers. And you can use that weird R. What that means is that it's any value for x. And then the range actually does have a stopping point. It's never going to actually hit 0. It's going to stay right below it. And so it's everything y values less than 0 this time, because it's everything below that. Y less than 0. You're fine. And then the last question, how does this compare to the parent function? We talked about this on Tuesday. The parent function is y equals 2 to the x. So how does it compare to that one? Y equals 2 to the x. That one starts at 1. So remember, it's like this. That's the same thing. Can you please discuss with your partner what's the difference between the one that we just wrote out, 1 times 2 to the x, and the one that you just did? Talk to each other, please. What is the difference between those two? Okay. Serenity, can you give me one? Let's get back to one thing that's different. So one has a 1. How does that compare? Maybe it wasn't clear enough. How does that compare to this one up here? So the one that has a 1 in front of it, what's the difference between that and this? They're close. They've got some similarities. This one also has a 1. What's the difference between that one and this one? Negative. And so what that does is, notice how it's flipped over the x-axis. The one that you did on Tuesday was going up and to the right. This one is still going up and to the right, but it's actually called a reflection over the x-axis because it's got -1. So because it's negative, it reflects over the x-axis. And we also have, so this one is 2, the other one is a half. So this one is a little bit like, say like squattier, it's like a shrink. We call that and you may have seen this on your homework the other day, it's called a vertical shrink because it's half versus 2. The larger number is going to give you a taller exponential function. Okay, we're doing one more thing, which is writing an equation from a graph. If you want to go ahead and start on that, I would start by making a table. So I'd look at my points and I'd make a table out of the points that I see. So look at your graph and you have 1, 2, 3, 4, 5 points that have been labeled for you. It's asking you to write an exponential function for this. So let's make a table. X, Y. My first point is 0, 3. My next point, 1, 12. Fill in the rest. You've got 5 points on this graph that are labeled for you. You okay? Our job, we can write this function as long as we know where it starts and what it's multiplying by. If we can figure that out, then we have enough. Okay, you can say it out loud. Where does it start? What's the y-intercept? 3. Y-intercept is 3. Where is x equal to 0? I'm struggling right now. And then it's multiplying by what? 4. So then when we write this, a times b to the x, a is where it starts, 4 is b, where what it's multiplying by. So I'm going to write this by the question, y equals, it'd be 3 times 4 to the x. Because it starts at 3, multiplies by 4. Yeah, Jackson?
How come you're not using like the f of x then? When do you use that?
You can use it if you want. So another way to write this would be like that. Instead of putting y, you'd put f of x. It means the same thing. You're just saying the output equals 3 times 4 to the x. So same exact equation. Okay, and then the next question, find the population after 12 hours and 5 days. So we have our function, or our equation. Let's do this separately. 12 hours, we'll do here, and 5 days. So you have to evaluate for both. 5 days is pretty simple. You just put it in for x, because x is days. The problem is 12 hours is not a day amount. What is 12 hours though as a day? How much of a day is that? A half. And so you can put a half or 0.5. And so this one is x equals 5 days. So you're going to plug into your equation twice. This one will be for 0.5. And this one will be for 5. Can you please go ahead and do that and compare with your partner, make sure you get the same thing. So what is the population after half of a day? 12 hours. What's the population after 5 days? Remember, when you put it in your calculator, you need to do the exponential part first. So like 4 raised to 0.5. And then multiplied by 3. Emily, how much after 12 hours? 6. So 6, we'll say 6 bacteria, that's a population. And then finish 6 bacteria after 12 hours. Karen, what do you got for 5 days?
3,072.
That is a lot. And that's after 5 days. Okay. You have, I think, 2 questions on the front. One, and you're answering those complete sentences. So how do I graph